Okay, everybody. So welcome to the HVAC filtering webinar. Today we'll be diving into a few key components, but first we want to talk about some upcoming webinars that we have coming up soon. We have solar energy for business on February 27th. You can learn more about how solar lowers operating costs and enhance sustainability. We have rooftop safety March 5th. Important safety considerations for working on rooftops. We have rooftop asset management technology. We can show you how advanced uses tools that can extend your roof life. We have top 10 things for property managers on April 9th. We got essential HVAC and maintenance tips for roofing and for HVAC and for solar, I'm sure. As well as we have our last webinar that we're going to be doing in May 21st that's going to go over to get you ready for the storm season. Best practices on HVAC, roofing, and solar as well. A little introduction of myself today. So I've been in the HVAC industry since 2002, started in my father's business early in life with my brother. Learned HVAC relatively quickly. I had a mechanical aptitude, so it came quickly to me. I joined Advanced Air Systems in 2017 as service manager and worked myself up to eventually division manager in 2021. I hold a state mechanical license and an EPA certification, as well as many other certifications in variable frequency drives, VRV systems, and heat load calculations. Today, I'm happy to share with you the different things we'll be covering today, as well as going over a little bit of our history. Advanced Air Systems was established in 1994. Rob started it as a subdivision to his already well-established roofing division. We specialize from everything from air conditioning installs, repairs, maintenance for commercial clients. We're a division of Advanced Roofing, so we're a top-ranked contractor. We're focusing on delivering as much HVAC solutions, everything from chillers to cooling towers down to mini splits, package units. We have you covered. So like I was saying, we cover new construction. We do installs for commercial buildings. We do retrofits, upgrading old systems to modern energy efficient equipment. We do replacements for aging equipment that you need to get replaced. We offer repairs, diagnosing. We also offer full maintenance contracts where we take care of your systems with preventive maintenance programs, keeping your systems running at peak performance. We take pride in our expertise and ability to handle projects of any scale, from small business to large commercial facilities. Our goal is to maximize HVAC efficiency, reduce energy costs, improve indoor air quality for all of our clients. We're giving away two cotton beach towels or a cup at the end of this meeting, so make sure that you stay for the end here. So let's get into the overview of today. We're going to be cover a few key topics. First one we're going to be going over is HVAC systems. We're going to go over the fundamental components of how they work. Then we'll dive into indoor air quality, HVAC maintenance, and the importance of clean air and maintaining your system. We're going to review some code changes as well as some other things that are changing in the HVAC industry. As the industry shifts, we'll see how they impact your businesses. Let's go ahead and we're going to start off with a poll, quick gauge of how familiar you are with the HVAC concept. So we have a couple things up there. What does BTU stand for? So go ahead and put your entries in there. We're going to give it a second for everybody to put their entries, and then we'll move on to the next slide. We're getting some results here, and it seems like we got 16 responses. It's like we're going to call it at British Thermal Unit. Correct. That is what BTU stands for. So let's go to the next slide and talk a little more about that. Okay. So here's the ABCs of HVAC. This is the terminology that we have. It could be kind of complex, but I want to go ahead and break it down for you, and we'll go over a few of these. British Thermal Unit, BTU, that's what it stands for, is the measurement of the heating or cooling capacity of equipment. Ton or tonnage is equivalent to 12,000 BTUs, And I get this question often is, is tonnage the weight of the equipment? Why is it called a ton? So it's just an easier terminology to refer to determine what the cooling capacity of that is. So for every 12,000 BTUs of cooling capacity that equipment can provide, it's 1 ton. So when we're talking about 10 or 5 tons of cooling capacity, we're talking about 60,000 BTUs per hour. Moving on to EER, that's the energy efficiency ratio with constant temperature inside and out. And then SEER is the different temperatures throughout the seasons. So that's more of a realistic test, an energy efficiency ratio rating. It's more real world. So if you're looking for that real world, energy efficiency rating, your SEER rating is probably going to be the most correct one. CFM is the cubic feet per minute. It's a measurement of airflow. RTU is a rooftop unit, typically self-contained unit on the roof, mounted to a curb, but it could also be a condenser as well. Sometimes we refer to condensers on the roof as rooftop units, but most of the time it's a package unit. AHU is the air handling unit. That's the unit that circulates the air through the building, filters it out, and also does the heat transfer, cooling down and removing the humidity and heat from the air. CU stands for condensing unit, which is like the pump, which compresses refrigerant and condenses it into a liquid. The chiller is used for heat transfer from water to refrigerant in a closed loop system. And a cooling tower is a device that removes waste heat from HVAC systems through evaporative cooling. We're going to go ahead and dive into the key components of a condenser. And the key components we always like to start with is the compressor, which is the heart of the system. The compressor is compressing that refrigerant that it receives into a high pressure gas. Then when we talk about the condenser fan motor, that condenser fan motor is pulling air across that condenser coil, which is removing that heat. That condenser coil is condensing that high pressure gas into a high pressure liquid that, once we move to the next slide, we can talk about what that's used for. So that high pressure liquid travels to the air handler, which the first thing it meets is the expansion valve. The expansion valve controls the flow of that liquid refrigerant, changing it into a low pressure gas. Then we have the evaporator coil. The evaporator coil transfers that heat from the air to the refrigerant that is evaporating inside the evaporator coil. So that low pressure gas is evaporating in the evaporator coil, pulling that heat from the air. And then the blower wheel and motor are used to facilitate the air movement across that coil and blow it throughout your ductwork, and that's the components of the air handler. Now let's talk about the whole refrigerant cycle in whole. Like I said, we started with the compressor. It pumps the refrigerant as a high pressure gas. Then the condenser coil releases that heat, turning and condensing that gas into a liquid. Then the expansion valve drops that pressure, turning it back into a gas. When the refrigerant turns back into a gas inside the evaporator, it picks up that heat and absorbs that heat and then carries it back to the compressor where we start the whole process again. We're back for another poll. What does IAQ mean? See some of the answers. Internal air quality, international, indoor air quality. Which one is it? Let's see. Okay, we're going to go ahead and call it. Yep, that's correct. It's IAQ stands for indoor air quality, 71%. Got it right. So we're going to go into indoor air quality. So indoor air quality is crucial for health and productivity. We spend 90% of our lives indoors, whether it's be at home or at our office. The air quality can be very poor in these buildings and in these spaces. And as we build our spaces more tightly, as with the new construction, code requires our buildings to be super tight. It can cause extra indoor air pollutants to be built up. And then just some of those pollutants are mold spores, bacteria, viruses, VOCs, if you ever hear, volatile organic compounds, carbon dioxide, ozone, just some of the few things that can be in a indoor air environment. So that's why making sure that we're using eco-friendly cleaning products and to reduce those VOCs and making sure that we have proper ventilation in our buildings is so crucial. talk about airborne pathogens. I think this video does a great job of explaining how just a sneeze can travel throughout the building. So we're going to go ahead and play this video and let them explain.
Are you sick? Don't you dare sneeze on me. Do you know how far your germs can travel? Normally you hold about half a liter of fluid in your lungs. So when you sneeze, you're able to spray as much as a water bottle's worth of mucus into the air around you. It shoots out of your mouth in the form of moist, germ-infested clouds, traveling up to 35 meters per second. That's fast enough to give you a speeding ticket on the highway. Once that cloud hits the air, it expands, breaking up into snotty strings, then a series of different sized droplets, all trapped in a turbulent gas cloud. One brave group at MIT discovered that the biggest droplets can travel up to 2 meters, about the distance between your desk and 2 desks away. But most other droplets? Those travel much farther, up to 8 meters. That's about 5 desks away. Not only that, the germ-infested gas cloud is less dense than the air around it, so it rises upwards, right to where ventilation systems and other people's unsuspecting noses and mouths await. Even though these are relatively smaller droplets, they're probably still teeming with harmful pathogens, like the flu virus. Even worse, depending on the ventilation, they can spread through a room in just a few seconds, and remain suspended for up to 10 minutes. Now, if you happen to notice someone around you sneeze or cough, you can hold your breath as you move out of range. But during the flu season, that might not even be enough, because there are danger zones everywhere, especially on surfaces like desks, doorknobs, and steel handrails. It turns out the flu virus has been found to survive for 24 hours on a steel surface. And if you touch that surface and don't wash your hands before eating, you may have just gotten infected. So let's say you go into work sick with the flu one day, and you start to sneeze. Now, according to one study, you'll probably only infect 1 to 2 other people. You're clearly showing symptoms of the flu. However, it's going to take a few days for symptoms to show up in other people you've infected. So those poor souls unknowingly also come into work sick over the next few days. And they will potentially infect 1 to 2 more people. In an office of 100 desks, this could mean 10 or 15 sick people by the end of 2 weeks. That's over 10% of the office. And all of it started with just one sick person, you. All thanks to the germ-laden cloud you so generously shared. So the next time you're not feeling great and you're sneezing up a storm, just think about your poor coworkers and take a sick day for yourself and for them.
Okay, so that was pretty enlightening, right? So good to see how far germs can travel, right? And especially as one of the things we're going to talk about next is humidity and how that plays a major role in the indoor air quality for you. So being in Florida, where we're primarily located, humidity is a huge issue down here. It's very hard for us to get the humidity down to the healthy zone that I'm showing in this chart. But we can, and we do it for a lot of our clients. We offer a lot of different HVAC equipment depending on your situation and ventilation requirements. We can size out a system that would work properly for you. But what we're typically seeing in normal systems in the indoor, like your house or an office space, we're seeing between 50 and 60% humidity, and that's acceptable. That's typically what most systems can do. If we have a outfitted proper system for a commercial building, we can get down to 45, but that's typically all you're going to see, and that's where we're looking to be. We want to stay in that healthy zone. So mainly because high humidity can promote bacteria, mold, dust mites, a whole bunch of issues. Low humidity can also cause respiratory irritation and increased virus transmission. So we're trying to stay in that healthy zone. What or who is MERV? So we're going to do another the poll here. So Martian on Elf. That's pretty good. I'm gonna go with that one. Um, so let's see how this pans out here. We're gonna go ahead and call it, but it's actually incorrect. So it's good that we're talking about this. MERV actually stands for minimum efficiency reporting value. Okay, so what we're talking about here is really the capabilities of which these filters can filter out. So we got a nice little slide here that shows the different things that each MERV rating can filter out. So you can look at your filters and check the MERV rating so you know what it can filter out and what it can't. So higher MERV ratings are definitely more capable of removing finer and finer contaminants. The only issue with that is as we raise the MERV rating, we do create the filter. The filter tends to be more restrictive, so you definitely want to check with your HVAC contractor that your system can handle say if you're looking to filter out virus carriers and bacteria, well, you're going to want a MERV 13 or higher. And you got to make sure that your system can handle that, because if you put too restrictive of a filter on an AC unit, you could cause damage to the motors and the components. So we don't want to do that. So always consult. If you want to raise the MERV rating of your filtration, always consult with your HVAC contractor, and he could tell you whether your system can handle it or not. So that just go ahead and take a look at that slide, and you can find out more information. So we're going to go into a little bit of the different components that are offered for indoor air quality. One of them that we always hear is HEPA filtration. HEPA filters are not typically installed on actual HVAC equipment. They're like a subsystem, so it'd be a separate machine with a HEPA filter and a high static fan motor that would be able to pull across that HEPA filter, and then that would move on to your HVAC equipment. So if you're looking for HEPA filtration, it's usually a large expense. They're very expensive equipment. They're really good at removing indoor air pollutants. So we typically see them on hospitals or clean rooms, that type of thing. So it's not in your office environments or condos or households typically. So then the next one is carbon media filters. We use carbon media filters for trapping odors. So if we have a client that's got an odor issue, we'll typically throw in some carbon media filters to go ahead and get rid of that odor and resolve that issue for them. So they typically don't use them, for just normal filter, media. It's mainly just used for that odor removal. So, but you can use them as normal filters. They're just more expensive than your standard foam and fiber filters. So the next slide will go over a little bit of the pros and cons of foam and fiber filters. This is your typical filters that you see in your HVAC unit from day to day. I would definitely always try to go with a pleated filter. You can see on the left-hand side, we have just the cheap poly filters. I mean, those pretty much all they do is filter out hair and large particles. They're really not doing much for your system. If you have multiple filters, you can put that one first to kind of get rid of the hair and large particles, and then have another pleated filter, something like a MERV 8, a MERV 6, right at your unit. Is what I typically recommend. Okay, and then next we start talking about air cleaning devices. One of the air cleaning devices that we install in HVAC units is a bipolar needlepoint ionization. Basically, this uses ions in the air to attract these particles and get them to stick together. When the small particles stick together and we create a larger particle size, that particle starts to get weighed down and starts to fall out of the air, and it's also easier for the filters to capture those particles. So using a MERV 6 or MERV 8 with a bipolar ionizer, you're going to actually make your filters more efficient, because it's going to bind all those particles together, make them into bigger particles that the filter can catch. So if you don't want to put a MERV 15, a MERV 11, or something stronger on your unit because it can't take it, I recommend throwing on an ionizer that's going to go ahead and pull those particles together, get them to stick together, and it'll capture them on your filter. So that's one of the devices we use. The next devices are UV light. UV light does a great job of killing bacteria. We typically only install it evaporator coils or area, or maybe the pans of the drain pans. The main reason for that is UV light is good at killing bacteria when it's exposed to it for a decent amount of time. A decent amount of time can be 1 to 2 seconds or so on to kill the bacteria. But when we don't use it for air cleaning because UV light, with the air systems have air flowing through them. Your standard 5-ton is 2,000 CFM, so the air moving through is not going to be exposed to that UV light for more than a second at all. So it's only be a couple milliseconds. So that being said, we use them to keep coils clean, keep drain pans clean. That's what they do a good job on. The one thing you want to watch out on is if you do have a UV light installed in your equipment, you always want to make sure that thing is off. If you are exposed to it, you don't want to be exposed to UV light. It could cause damage to your eyes and skin. So we do like using those, but in specific cases and specific solutions. Next one is that ozone generators. We don't use these very often. The only place we do use these because ozone can be damaging to your lungs and can cause health risks. So we don't use this in occupied buildings. When COVID first happened, we were using it a lot to clean spaces that weren't occupied. So that's what it's good for. Also, when we're looking to convert a space, maybe from like a cigar bar or cigarette bar, something that has a lot of smoke smell, we can get rid of that smoke smell pretty efficiently with an ozone generator. But then again, we usually clear those areas, have the ozone generator in there for 24 hours, and then we have the space ventilating for 24 hours, so there's no issues with that. So one of the things that we recommend that's kind of a culmination of air purification technologies over the years, it's got a lot of different functions, a lot of different technologies built into it, is the REMI Halo. The REMI Halo is a great product that we use. It releases hydrogen peroxides into the air, and this video will go ahead and show exactly what it can do.
The high occupancy of commercial buildings makes them one of the most polluted indoor air environments. The REMI Halo by RGF can reduce these contaminants at the source. Installing easily into any ducted air conditioning system, the REMI Halo is designed to recreate the natural way the environment removes impurities in outside air. It does this by sending out airborne hydrogen peroxide into the space where you work and breathe, attacking microbes like bacteria, viruses, and mold spores, and reducing impurities like volatile organic compounds and odors in the air-conditioned space of the building at the same time. The REMI Halo improves your existing filtration by causing airborne particles and allergens to stick together, increasing filtration rates and energy efficiency without sacrificing airflow. Medical facilities using the REMI Halo can reduce airborne pathogens, and long-term care facilities have saved dollars by eliminating chemical odor cover-ups and increasing worker productivity. Schools can see a decrease in sickness and absentee rates. When you install a REMI Halo, you will notice the difference in the quality and freshness of the air you breathe and wonder why you did not take this simple measure sooner. To find out more, visit or talk to your local air conditioning and heating contractor to start breathing cleaner, fresher indoor air.
So that's a little bit on the REMI Halo. It's definitely an awesome device that we use. We even have it in all of our office buildings. So we definitely recommend that as one of the main products we recommend of all the air cleaning devices first to do. Okay, we'll go ahead and move to the next slide. It's more about the REMI Halo. Just FYI, if you guys want more information about it, feel free to reach out to me at the end of the meeting, and I can give you more information about it, and we install them and provide them for you. Go ahead to the next slide. So I get a lot of questions about cleaning ductwork. I'm going to make a few comments about what I feel is what it's good for and what it's not good for. So in South Florida, we typically have a lot of the duct systems that I'm showing in this slide. We have a lot of flex ductwork that you can see on the bottom left. We have a lot of fiberboard in the middle, and we have a lot of fiberglass internally lined metal ductwork, as you can see on the right. On the top right there is the brush that is typically used in duct cleaning. Okay, so that brush is spinning and scratching and inside the ductwork, and that's how your ducts are cleaned with a duct cleaning machine. So anytime we talk about duct cleaning, that's the type of equipment we're using. So that tip there is spinning and trying to scrape off any dust or debris that is in that ductwork. The reason I don't suggest this for these types of ductwork mainly is because these types of ductwork have open fiber glass fibers in them. So the flex ductwork, I don't recommend it because the you can see that internal liner in the flex ductwork is it can become very brittle. It could break, and then once you have a break in the flex ductwork on that liner, you're going to be leaking air out of that. And we don't want that to happen, especially if you have old flex. So I don't recommend cleaning flex at all ductwork, and I definitely don't recommend cleaning old flex ductwork. And if we're talking about houses, almost 100% of houses in South Florida are ran with flex ductwork. Then the next one we have is ductboard, which is that one in the middle of the yellow inside. I don't recommend cleaning this. Mainly, like I said, this is exposed glass fiber on the box. It says it causes carcinogens. It's a known carcinogen. So I don't want to disturb those glass fibers and get them in the air. So I want to maintain keeping those glass fibers attached to the board. Any dirt or buildup that has gone built up on that ductwork, I would suggest just to leave. I really don't see how it could cause any better indoor air quality. I mean, even the EPA has stated that duct cleaning has not proven to improve indoor air quality at all, if any. So the only one I do recommend cleaning is metal ductwork, but you have to have a very specific metal ductwork. It cannot be internally lined like the one we see on the bottom right hand side with that black and gray internal glass fiber insulation there. Mainly because you're dealing with the same thing with a duct board where that glass fiber can be broken and then can be put into the airstream. One thing, you could break the insulation and cause, sweating issues and more maybe mold buildup because of that, because you don't have proper insulation. So the only ductwork I would recommend cleaning is internally metal. So it would have to be a metal surface on the inside of the ductwork. And the only one that I could probably tell you if you have that type of setup is your HVAC contractor. So just consult with your HVAC contractor, ask him if you have, hey, is it metal lined? Is it metal lined ductwork or is it fiberglass lined ductwork? If it's metal lined, you can clean it. If it's fiberglass lined ductwork, I would suggest not cleaning it. So that's my 2 cents on duct cleaning. Now we're going to talk about maintenance. Some of them, you want to make sure that you're maintaining your regular maintenance. It's going to save you money. It's going to improve the indoor air quality. Well-maintained systems use 15 to 20% less energy. And by maintaining these systems, you're going to reduce the costly breakdowns. You're going to prolong the life of the equipment. And we always suggest that you have a certified contractor do these maintenances, but if you're going to have your building engineer or staff do filter changes and drain line cleans, we suggest at least that you have a mechanical contractor come by, at least check the rest of the functionality of the equipment and the components of the system to make sure everything's running properly. Cooling towers, we have a lot of cooling towers down here in South Florida across all of the different condos and buildings and high-rise buildings, because we use cooling towers to cool down the water that our equipment uses in our buildings. And they need to be maintained. And one thing we suggest, the minimum cleaning we suggest for cooling towers is twice a year. We like to do that maintenance in the fall and then in the spring. Make sure that your cooling towers are clean and functioning properly to get you through the summer months so you don't have any breakdowns. There's a lot of components to cooling towers, a lot of different aspects that need to be looked at and make sure that they're functioning properly. Your cooling tower is not supposed to be leaking water. So if your cooling tower is leaking water, you have an issue. So we need to have somebody address that. And mechanical contractors, I was saying, you want to make sure that you're taking care of your cooling tower, make sure you have chemical treatment. We don't want any issues with bacteria buildup. Legionnaire's disease could be caused by the air or water molecules that are leaving your cooling tower if it is infected with that. So you want to make sure your cooling towers are clean to prevent any health hazards or any legal issues as well. I'm going to talk about equipment shortages a little bit. So A2L, we're going to get into what exactly A2L is in the next slide, but I want to talk about, we're going to have a couple equipment shortages right now because we're switching refrigerants. All the vendors are shutting down their 410 equipment and they're switching over to A2L refrigerants. This is due to greenhouse gas emissions to try to reduce global warming. So this is going to be a long-term initiative that I'm going to talk about a little bit more, but I do want you guys to understand that there can be significant delays with large commercial equipment. Residential equipment is just starting to arrive now with A2L, but commercial equipment is going to have further delays. I would just try to get, if you need equipment now, I would purchase it now. Try to get on the wait list because I expect by summer we're going to have some serious issues with equipment delays. Okay, so going into a little bit more about A2L. So, like I said, this is an initiative due to EPA's regulations and the high global warming potential of 410A. So when we removed from R22 to 410A, that was due to ozone. We were depleting the ozone with the chlorine inside of the R22. Okay, so that's why we switched from R22 to 410A. The problem with 410A is actually more of a greenhouse warming potential, global warming potential than R22 was. So now, and then we're all worried about making sure that we're doing what's right for the planet by lowering those GWP gases. So the global warming potential of 410A is 2088. So that's a huge amount. So we're switching to low GWP refrigerants like R454B and R32. Now, that is one of the problems that you'll be seeing is that some manufacturers decided to use R54B and other ones decided to use R32. So when we were going from R32 to 410A, we only had one refrigerant that we were dealing with. Now we're going to be dealing with two different refrigerants. So your AC unit may run on 454B if you have one brand of equipment, and then it may also run on R32 if you have a different brand of equipment. These are not transferable. Your equipment will require, if it had R54B, it's going to require R54B, and if you have R32, it'll require R32. So, and this is the year that we're going to be switching over to that. That's the one key potential. Now, the other issue with A2L refrigerants is by switching to A2L, and what A2L stands for is really a classification of refrigerants. There's A1 refrigerants, A2L, A3L refrigerants. It's basically, this rating is to talk about the flammability of the refrigerant. So A2L refrigerants are considered slightly flammable or mildly flammable. So there's going to be a whole host of different safety devices that are going to be built into these new HVAC equipments to detect leaks, prevent any ignition issues, and there's going to be safety shutoff valves if there's any leaks. So they're still going through implementing all these different safety devices and finding out what exactly how each one is going to be implemented. But your new equipment is going to have these safety devices. And when we're talking about large facilities with this equipment, so we're talking about chillers, you're definitely going to have refrigerant monitors, evacuation as far as exhaust fans. If you don't have those existing, you're going to have to upgrade those because this refrigerant, compared to the previous refrigerants where they were not flammable, these refrigerants are flammable. It's not like propane. Now, we eventually in 20 years so we should be switching to something similar to propane. So it's going to get more flammable as we try to lessen the global warming potential, but hopefully will stay for a decent amount of time, so we don't have to worry about that. Another issue that we're facing just recently, and we're kind of unsure what's going to happen, is tariffs. So we're having a big cost increase with just the A2Ls. You should expect about a 10% increase on your current HVAC equipment pricing with A2L equipment. With the tariffs, we're expecting anything from 15 to 30% added on to that already 10%. So if you think equipment is expensive now, it's going to be more expensive in the next coming months, depending on how these tariffs go, but it's definitely going to be more expensive due to the A2L refrigerant. So, again, buy your units now if you can, because again, you're going to expect at 10% to, like I said, could be 40% if you compile these with the tariffs. on these equipment. So just something to, I know you guys do a lot of budgeting for your buildings and then for your different condos and stuff that you guys work with. So I just want to make sure that you guys understand what's potentially coming down the road. So you add that, 15 to 30% to your budgets on your HVAC side. Okay. Think that pretty much wraps up everything we were going to go over today. If you guys have any questions, I'll be available at the end of this meeting to answer as much questions as I possibly can. My contact info will also be at the end of the meeting. So if you want to reach out to me and discuss anything, feel free to reach out to me. I did want to talk about a Riverside Hotel project we just completed, where we changed out chillers and we changed out some air handlers for the building. So we did some hotel renovations for the Riverside Hotel, and we put a new chiller in for them. It was a great project to work with them on. We've done a lot of work with them in the past, and this is just another great project we were able to do with them. We were able to minimize the guest disruption, and we redid those rooms. So if you do stay at the Riverside Hotel and you stay in one of the new rooms, you can see what we did on the HVAC and should be able to enjoy that the new quality of air in there. So like I said, I'm here. We're available for any needs that you may have. Feel free to reach out to me, and more than happy to help.